All right, let's review Newton's laws of motion. So let's title, we're going to do a tree map. On Newton's 3 laws. Okay, we've got Newton's 3 laws. We're going to do a tree map. We're going to talk about his first law. We're going to talk about his second law. And we'll talk about his third law. All right, let's move over here to the first law. All right, the first law is summed up with one word: inertia. Now, it's always stated that inertia is objects in motion will stay in motion until acted upon by an unbalanced force. Also, objects at rest will stay at rest unless acted on by an unbalanced force. So we're just going to say, essentially, objects want to keep doing what they're doing. Okay, so for these notes, we're going to make it 8th grade language, objects, and organisms. So objects want to keep doing what they're already doing. So if the object's at rest, it's going to stay at rest until it's acted upon by a force. So objects want to keep doing what they're already doing. If they're moving, they want to keep moving. If they're at rest, they're going to stay at rest. So the periodic table that's sitting on your desk, it's going to stay there until what?
We move it.
Exactly, until you move it. And we're going to use that periodic table in a minute. So the periodic table will stay on the desk. Okay, the periodic table will stay on the desk until I move it. And that is Newton's first law. What's the one word? What is the one word? Good. Inertia. Inertia is a state of being. All right. And then we've got Newton's second law, which is essentially a formula. Force is equal to mass times acceleration. You're going to get this formula on, this formula is on the back of your periodic table, and you will get this for the STAR test. And if it helps you to use the triangle, we know that mass and acceleration are next to each other. So that would leave force being here. What is going to require more force? Throwing a tennis ball or a bowling ball? Okay, it's going to require more force to throw that bowling ball than it would. So we'll write an example. It will require more force to throw a bowling ball than a So more force required to throw a bowling ball than a tennis ball. Which will require more force to stop? The Rock or Kevin Hart? The Rock. Okay. All right, third law. Essentially, we're gonna write action, reaction. For every action, there's an equal and opposite reaction. All right, and we can demonstrate it visually. I'm not a good drawer, so remember we had, I get to say Newton's balls. Newton's. Okay, so this is actually called Newton's cradle. Okay, if we moved one ball out this way, how many balls will come this way? 5. One, good. If we move 2 balls back, 2 balls would go that way. So for every action, there's an equal and opposite reaction. Let's give an example. Okay, if you kick your foot back, if you're on a skateboard and you kick your foot back, what does the skateboard do? Goes forward. Good. So we're going to write, when I kick my foot back, the skateboard goes Can y'all end the video for me?